Okay, tutorial 1, question 13. You have your question paper with you. Okay, let's look at question 13 together. Okay, it says it gives you a condition about a function gx. It says that 1 minus x squared is lesser than or equals to gx, and it's lesser than or equals to cosine square x. This question wants you to prove that g is continuous at x equals 0. So first and foremost, we need to show that g0 is defined. So what you're going to do is put x equals to 0. You're going to get 1 minus 0 square g0 cos squared 0. So give you 1 g0 1. Therefore g0 must therefore be 1, which is well defined. What like? Is there issue, Aditi? You saying something?
So then as you know the only possible value of g is 1 for the inequality to still hold.
Okay. Second point you want to do is, okay, since limit when x goes towards 0 of 1 minus x squared is equals to 1 is equals to limit when x goes towards 0 of cos. So by the squeeze theorem, gx therefore is equals to 1. Number 3, you noted that g0 is equal to 1 is equal to limit x goes to 0 of gx. Then say by 1, 2, and 3, g is continuous at x equals to 0. Right. Okay, so these are the 3 important ingredients that make up the conclusion that g is continuous at x equals to 0. Okay. If you have no question, I'm going to move on to question 14. You need me to flip back to 13 first? See 13 again? Okay, 13 again. Let's pause a moment. As you are jotting down, okay, like eating small bite in class, I'm actually okay. But I'm not sure about your year 5 what does she say about eating in class? Okay. Actually, I'm alright because I think that you're old enough, you keep the place clean. I think quite okay. So if you need to eat, just do it. Go ahead. No? Yeah. Because I don't want you to be hungry. No? Because for children like you, you're growing up, you need to eat a good breakfast. In fact, for everybody else, for everybody else. Okay, 14. For question 14, you're given a function. This function, right, is continuous continuous on 0, 1. Alright, and then he also told that this function is bounded within this interval for x in this domain. Right. So part A wants you to prove a certain result, Part A wants you to prove a certain result. So to prove the certain result, let's start with case 1. Case 1, if f0 is equal to 0, we are done. Right, if f0 is equal to 0, then we have what the question wants you to establish. Right. Case 2, if you is there something on time?
No, I need foolscap.
Oh, foolscap paper. Just do it on your PLD. In fact, for your generation, it's even more important for you to actually come to class with a PLD and be writing.
I overdated my PLD.
Okay, bad suggestion. Okay, erase. Your PLD is still working now? No more. Okay, case 1, right? And case 2, they are the trivial cases. In case 3, when this thing happens, then we define, let gx be equals to f of x minus x. So we say that g is continuous on 0, 1 because f is continuous on 0, 1, and okay, this function x is also okay. To write like this is very funny, right? It's very funny. Maybe maybe I should say okay, maybe I should just not say this, because just say x is continuous on the interval is very funny. I think that's good enough, because you see the thing is, because this function is continuous, and this one is a kind of polynomial, and we know that polynomial is obviously continuous throughout the entire real line. So because fx is continuous, you minus another continuous function we have learned previously, right? If two functions are continuous, the difference is also continuous. So I think that in writing, I think it's good enough to just say this, because the other part of it, I think that if you are into this business, you know that that is the case. Okay. Then let's calculate G0. G0 is going to be f of 0 minus 0. Okay, and this thing is going to be more than 0. You know why? Because f of 0 is not 0, and we have the condition that this thing, remember? Because f0 is not 0, and the fact that fx is between 0 and 1, therefore fx has been more than 0, and f0 has been more than 0. So therefore this portion here, right? You're left with, of course, f0 lah, no? But f0, as I told you, because it's not 0, therefore it must be more than 0. You see the logic? Now you begin to realize how come I want to consider different cases, because I need this condition, is it? I need this condition to say this, right? Then, as you can guess it, the next thing that I'm going to look at is G1. G1 is equal to f of 1 minus 1. And this thing less than 0 because f of 1 is not 1. And for the same reason, because f1 is not 1, right? So therefore, in this case, f1 must be lesser than 1. And something lesser than 1 minus 1, therefore, is negative. So, gosh. So you say by IVT, there exists C element between 0 and 1 such that G of C is equals to 0. Why 0? No? Because 0 is a number that is between negative and then a positive. You know what I mean? And if GC is 0, this means f of C, right? F of C minus C is equals to 0. So therefore, we have a FC which is equals to C. And then we are done with the third case. You see, you have G0, G0 is negative, positive, right? G0 is positive, right? And then G1 is negative, right? And then because it is continuous on a closed interval from 0 to 1, IVT says no matter how you join them up, right? No matter how you join them up, there's always a value C in between this and this point where GC is 0.
Alright, then
Right. Okay, let's pause a moment. So you see an entire page. I beg pardon? Okay. You see, I needed this case 1 to take care of the case if f00 and then f1 is equals to 1 for case 2. Why I need to consider this separately? Because in case 3, right, I needed this condition and this condition to establish. Otherwise, it won't work. I needed these two conditions in case 3 in order for my arguments to work. That's why I've considered case 1 and 2 separately to make sure that I have a case 3 that I can affirm the condition of more than 0 and less than 0, and therefore I can then use the IVT to conclude that there's something between map to 0. You may think that, wow, how come I know I need a case 2? It's because when I try case 3, I realized that naturally, all of us will do case 3 first. But in working on case 3, you realize that your argument won't be strong because it will come to the step that you can't tell conclusively that it's really more than 0. You can't tell. True or not? That is where it prompts you to say, maybe you want to do something about it to resolve this portion here. You know what I mean? Because if you have started off with case 3, you will definitely come to this point where you can't say it conclusively, and that prompts you to think of a workaround, and that's how I came up with case 1 and case 2. So I actually did case 3, then I find it didn't work like that. Then I roll back and say I got to do a twist to it. Okay? And then the whole argument 1, 2, and 3, case 1, case 2, and case 3, it covers all possibilities. Okay? Okay, there's question 13. Oh, sorry, 14. Okay. Any other question to raise? Almost. There's almost. B. That's part B. Mostly, yeah? Okay. Right, so you're good. are going to part B. Okay, question 14B. 14B has the same context as 14A, that the function is continuous on the interval, and they're given the condition that it also ranges between 0 and 1 for the function f. So now they want to prove another condition that fc is equals to this thingy, right? So you want to start off by defining a function. Say let gx be equals to 2x f of x minus 1 plus x. So then you say g is continuous on 0, 1 since f is continuous on 0, 1 and 2x 1 minus x are polynomials. So we have learned previously, if you have polynomial functions, right, they are continuous everywhere. And then we have also learned that if a function is continuous, you times with a continuous function, it will be continuous. If you add or subtract to a continuous function, it will also be continuous. So therefore, that affirms that the function gx is also continuous. Okay. So for this question, let's have a case 1, If g1 is equals to 1, okay? If g1 is equals to 1, then 2 times 1 f of 1 minus 1 plus 1 is equals to, okay, okay, I think 0. 0. Okay, 0. Okay? If g1 is equal to 0.
Should they be at 1?
If g1 is equal to 0, let's see first, okay, let's see how it works, okay? If g1 is 0, then f of 1 will be equals to 1 minus 1 over 2 times 1, and then we are done. So if g1 is 0, right? If g1 is 0, f1 is equal to this, and you want to note, if g1 is equal to 0, right? This will give you f1 is equal to 0, 2. Right, so note this.
So does it matter if you use G or F to explain for case 1? Starting from G or literally just like substituting straight into the function.
Yeah, so you say if f1 is equals to 0. Okay, so there's a point raised here. Say it says why don't we say case 1 that f1 is equals to 0, and say that this one leads me to say that f1 is equals to 1 minus 1 over 2 times 1, and we are done. I think it's okay then. Also can. Okay. So Brian in front says I probably could just do it with f1 equals to 0 to conclude that we are done for this simple case. Okay. case 2, okay, G1 is not 0, right? G1 is not 0. Then we want to calculate firstly G0. Okay, what will G0 be? G0 will be 2 times 0 f of 0 minus 1 plus 0, and this gives you minus 1, which is less than 0. Okay, then calculate G1. G1 will be what? G1 will be 2 times 1 f of 1 minus 1 plus 1. This gives me 2 of f1. Now in this case, right, this is not 0, no? Because we already say that G1 is not 0, see? Right, we already say in this case that G1 is not 0.
Wait, but then, like 2 of F1 is 0.
No. Because in our case 2 is a case where G1 is not 0, right? We have computed G1 and G1 ended up with this line, right? So what makes you think that F1 is 0? What makes you think, Aditi, what makes you think that F1 was 0? Right. So because this is not 0, it therefore implies that this 2 of F1 must be positive, you know. Why is it so? Because Fx is between 0 and 1. And if F1 is not 0, because it cannot be 0, because it's 0, then G1 will be 0.
Oh my god.
So therefore, F1 times 2 has to be positive. So what we have, therefore, is, okay, let me erase. Okay, let me erase. Okay, Ryan, say. Okay, 大家冷静啊。Okay, up to here, all back in. All back in, right? You agree? So maybe I'll just straight say like that. Can? Good? Right. Say too much, get confused. Okay. So because G0 is negative and G1 is positive, we can use IVT now. No. So there again, you realize that how come by the case 1? Now you realize actually I needed this condition, you see. That's why I consider case 1 separately, you see. It's the same thing. I also started off with case 2. And somewhere down the road, I realized that to make this conclusion, I don't have enough bullet, you know. So I know that there's something need to be. So that's why I started off with case 1. That's the reason. It's always like this, no? It's always like this. Okay, that being the case, I am now able to now use by IVT, there is if C inside here such that G of C is equals to 0. So this implies that what's my function? 2C f of C minus 1 is equal to 0, and finally we are done.
How do you know like what numbers to submit? How do you know to like?
Actually,
They only give you like 0 and 1, so like just put it up.
no, she's wondering how I got the case 1 rather. More like how I know to do case 1. As I told you, I tried case 2 without case 1 at first, but when I reached this line, I knew that something is not strong enough. I haven't a strong enough condition to prove that it is more than 0. That's the reason why I actually created case 1.
How do you know it's not strong enough? You go
Because you reach this line, right? Reach line, you can't tell whether or not is it more than 0 or is it equal to 0. You can't tell. You can't tell. This case 2, because why I did it, right? Okay, actually I didn't have this. At first I didn't have this portion. At first when I did this question, I just bulldoze. What I bulldoze now, I just started off with this function, and I tried to calculate G0 and G1. G0 is not too bad, but G1 didn't work. Then I therefore know that I need to do a bit more work to make the whole proof more convincing. So with the case 1 and case 2, after case 1 is dealt with, right, I now rule out case 1 and just deal with case 2. You know what I mean? Yeah. So there's something that is like this in proof. And so also the way you carry out police investigation, you got 3 suspects. Okay, so you think that you say if the first one is the culprit, you have done this, and then you say, okay, if now this is not the culprit, then you just narrow down. What do you say? Oh, how do you create this GX lah? Okay. Actually, one student in their class use GX as fx minus in their class, right? Someone actually say, okay, discussion. Say, why don't you let GX be this? Be f of x minus 1 minus x over 2x. No? You know what? Someone in the class, but typically I know that if you have an x on the denominator, 0 can't fit in very well, typically. Yeah. So that prompts me not to use this one instead. So you could try others if it works. Yeah. But actually, question 14.A gives you an idea. But 14A provided you with a function. And 14B is you need a good pair of eyesight, a good eyesight. It's instinct. Right. Okay, that completes our 14B. If you have no question to ask, to raise, let us now progress to the next item. I intend to actually run through the assignment, You had the assignment on the handphone, right?
Yeah.
Assignment 1, number 1A. 1A. Alright. Okay, you have a question paper with you now. So let me do it on a clean page. So can you exchange script with people who have already done? Because I want you to check each other's work and see what are the common mistakes that people could make, or what are the strengths that they have when they did their sums, Some people might have a better method than yours, you see. Okay, minus 3, this x plus 6 minus x over x squared minus 4x minus 21. So for this question, what we're going to do is we are going to multiply the top and bottom by the conjugate, and which is what? The conjugate they're going to multiply with is this one, 6 minus x, and then upon multiplying, what we're going to have is on the numerator, you'll be left with Okay, you'll be left with x squared minus, okay, x squared plus x minus 6, and then on the denominator, x minus square of 6 minus x. Right, and then you can factorize the numerator. When you factorize the numerator, you're going to get x plus 3, x minus 2, and then this is x minus 7, x plus 3, x minus 6 minus x. And then there's a cancellation that you can do here. So upon cancelling, you're now putting x as minus 3. And in the end, what do we have? minus a plus, okay, in the end, minus 1 over 2. I think it's 12. Is it negative 1 or 12? So if you get this thing fully correct, you get 2 marks. So award 2 marks to your friend. If your friend gets the method but didn't get the final answer, it's only 1 mark. If totally correct is 2 marks. If the method is correct but answer is wrong, yeah. That's 1A. Tingwei, are you checking somebody else's work? Whose work? Okay, hers. Okay. Did you get correct? Okay. You didn't, Tingwei didn't get correct. Gosh. It's very embarrassing, you know. Disposal. Okay. So in question 2, right? We can do this question by again performing factorization. So that gives you x minus for the numerator, right? Okay, this is also a factor, no? So the thing then is, thank you, root 2x squared plus 2x plus 2 root 2, is it? Thank you. So Ryan fed me with this long division thingy.
I had to do the painful long division thingy.
No, you shouldn't know. You're not eating long division, right? You just did by comparing coefficients. The numerator is picked up by comparing coefficient. You don't have to do the painful long division, you know. You just have to compare coefficients will do. Huh? Okay, if you were to do this question by comparing coefficient, right? So see this is x, right? Obviously, it's easy to obtain this one and obtain this one, you know, quite easy. Okay, to obtain these two is quite easy. Okay, so to do it by comparing coefficient, you want to realize that it is quite easy to get this one and get this one, because you will need this one to times with x, to give you the root 2 x cubed. You need this one to times with this one to give you minus 4. So the first and last are quite easy, but it's the middle one that is a bit hard. But how do you do it? You take this times this, it gives you minus 2x squared, right? So that suggests to you that you need a positive 2x squared, which comes about when you do this. That's why you will know, therefore you need 2x. Yep. Can you factor out the root 2 first, is it?
And then after that you use difference of 2.
Sure. I think you can. Yes. So another suggestion given is, why don't you take out root 2 first, and then the difference of 2 cubed, right, has a known factorization formula. Yep, it's true. It's true. Okay. Okay. Now having done so, we now want to press on to actually calculate the limit. This will give me 2, 3, 4, 5, 6. I think it's 3. Is it 3?
Yeah, 3.
So, thank you. So once again, if the method is correct and the answer is correct, is 2 marks. If the method is correct but the answer is wrong, 1 mark. Okay, that's question number 1. Okay, wait. Okay, number 1 already. Okay, then let's do number 2. Question 2. Any look back question 1 again? Anyone? Okay. So you want to first and foremost calculate this, no? Limit when x goes towards 0 of the sine square 2x over 2x square. You want to calculate this as like that, no? 2 limit x goes towards 0 so this gives you just 1 square, so it's equals to 2. Okay, for number 2, limit as x goes with 0 of the right hand side is just 2. Yup. Sure.
Bye.
By the squeeze theorem, limit pi is equals to 2. And because the limit of fx exists, we can then say that limit x goes towards 0 Because if both limit exists, we can do this, right? And then the top become limit x goes with 0 of fx, and for denominator it's just pi, and then therefore okay, that is your number 2. Yo.
Can I like multiply the inequality?
Sure, you can. Yeah, you have multiplied throughout by 2x squared, is it? Or is it multiplied by pi cos x over pi? Is it? It works. Does it work? Sure. So once again, class in the working, right? You must show this part of the question, this part of the calculation, and then the conclusion. 1 mark each. If you are going towards 0 from the right, then this becomes 1 plus x over x. It is square root.
Oh damn! Can I say that?
And then when you reach this stage, you want to do it by the conjugate method. By the conjugate method, after tidying up, you would arrive at this line. And then this gives you half. So for part 1, again, if the method is correct, answer is correct, 2 marks. If the method is correct but answer is wrong, it is only 1 mark. Okay. Okay. 3 part 1. Any questions? In 3 part 2, it asks you, is G continuous at x plus 0? You want to try working out this one, because you can check for the limit on the left and on the right. It's different,
No, it's the same as it's using the same equation.
Aditi, looks are deceiving. Look more carefully. Okay, to do this question, like what she said, everything looks the same, but
No, but you're using the same equation.
Aditi, hold your horses. Okay, class, if you leave to think that they are the same, the truth is they are not. Aditi, the difference lies here.
It's gonna be negative x squared.
Brilliant! Who's that?
Me.
Okay.
Because I got the question wrong in the exercise.
Okay. Tingwei, did you get correct? Part 2? You knew it's not the same, right? It's not the same, If you live to think they're the same, you have been deceived. You are just naive.
I've been deceived.
But it's still zero.
没有，不是。
They basically just
Okay, root x
Oh
is
my
negative
god.
square.
what?
Is it root x?
Okay, that's not very good.
You should have noted that it's 3 marks, 2 marks, isn't it? It's not just 3. Okay, like for example, right? For example, how much is this? 2, right? If I ask you, what will this be? But if I ask you,
Then minus 2, then they become the same thing.
if your x is negative, can you see? If your x is negative, right?
Wait, but that's positive. It's negative or negative?
No, if your x inside here is negative,
See the negative x as in you want it to be positive, but x itself is negative, so you put the negative x and the positive.
Yeah, but then in the end it will still cancel out to become positive, right? So why can't you do that for?
you see, you're right. If this x is negative, then negative x is positive, isn't it?
Also, it's become absolute.
You're right. Okay, so following what he said, class, say after me.
That's unfortunate.
Okay.
What happened? Why didn't you